What is wave? Wave is a disturbance that transfers energy from one position to another without the transfer of matter. A disturbance that transfers energy from one position to another without the transfer of matter. That is wave for you. Now we proceed to types of waves. We have two major types of waves. Number one, we have the mechanical wave. Number two, we have the electromagnetic waves. These are the two major types of wave that are available to us. Now, if you talk about the mechanical wave, you must know that it is that type of wave that needs medium to travel. It requires what we call material medium to travel from one location to another. Examples of mechanical waves include waves on rope, sound waves, water waves. These are examples of mechanical waves. Now we proceed to electromagnetic waves. In electromagnetic waves, wave itself does not need any material medium to travel. It travels in a vacuum. No need for any medium. It can travel without a material medium. Take note of that. Examples of this includes radio waves, light waves, gamma ray, X-rays, etc. These are examples of electromagnetic waves. Now we proceed to the next part, basic terms in waves. Now we talk about the basic terms in waves. We have up to 4 majorly of them. Number one, we'll be looking at wavelengths. Wavelength is represented by the symbol. That's the number one, wavelength. This is the symbol for wavelength. A Greek letter called lambda. That is the symbol for wavelength. Take note of that. And we'll talk about wavelength. We are referring to the distance between two consecutive crests. Now, the unit of wavelength is meters. And if we talk about the formula for wavelength, we have that lambda equal to the speed of the wave all over frequency of the wave. That is the formula for wavelength. Speed of the wave or velocity of the wave over frequency of the wave. That is wavelength. Now, have we noted that? Number two, we have frequency itself. If we talk about frequency, we are referring to the number of waves produced in 1 second's unit. Number of waves produced in 1 second's unit. That is frequency, which is number two. And this is the symbol for the frequency we are talking about. Now, it has units. The unit of that particular frequency is hertz. That is this hertz, which is abbreviated to be this. This is the unit for frequency. Let's take note of that. And what is the formula? If you just, of course, you know what to do here. It's the formula. We have frequency equal to V over lambda. That is one of them. It also have 1 over period, or frequency itself is equal to 1 over period. This is another formula for frequency. That is number two. In number three, we have amplitude, which is represented by the letter A. Amplitude, represented by the letter A. Now, if we talk about amplitude, we are referring to the maximum displacement of a particle from its equilibrium position. The maximum displacement of a particle from its equilibrium position. That is what amplitude stands for. Now, the unit of amplitude is the meters. That is the unit of amplitude. Though it depends on the form of the question, but the basic unit there is meters. It has its formula. And when height is given, amplitude is usually equal to h over 2. That is amplitude for you. Now, that brings us to the fourth one, which has something to do with wave speed, which is this wave speed. Now, if we talk about the wave speed, we are referring to the speed with which the wave travels. The speed with which the wave travels is called the wave speed. Now, this is wave speed. We can bring out the formula first. Like from here we have seen. So we say wave speed is equal to lambda times frequency. That is wave speed. You can also get other formula beside this for wave speed. So another way is this lambda over period. Now, the next question is, what is the unit for wave speed? It's the same thing as meter per second. These are the basic terms in waves. Let's take note of that. Now, we want to proceed to the general wave displacement equation. This is the general wave displacement equation. A sign bracket open. We have our this minus our kx. Now, this is it. Let's describe each of them. Where this y itself, the y itself stands for displacement of the particle. Y represents displacement of the particle. Of course, we already know what our A stands for. That is the amplitude. A stands for amplitude. Then our W here stands for angular frequency. W stands for angular frequency. Of course, this is not the number W, you know. Our T stands for time. The T there stands for time. Our K there stands for wave numbers. This K stands for wave numbers. K for wave numbers. Now, the X here stands for distance along the wave. Distance along the wave. Don't forget, this is just the introductory part of wave. We have more to talk on. Watch out for it. Save for future reference. Share for others to benefit. See you in our next class.